All right, guys, here we go again. Transformations of linear and absolute value functions. We're going to take the linear, which are lines, absolute values, which are v, and kind of move them around a little bit. Okay, a couple things here on this first slide. The main thing I need you to pick up is if you see a number added on the outside of the parent function, like absolute value or a line, it's going to move your graph up or down exactly whatever that number is. Like if you look at this picture, the graph in the middle, that's the parent function right there. Look what they did. They did x plus 2. The whole function moved up 2 units. Minus 2 on the outside. The whole thing went down 2 units. That's what they need you to see. Also, if you look down below at the bottom picture, if the number is inside the absolute value, inside the linear, inside whatever, quadratic, it shifts your graph left or right. But here's the deal. It goes opposite of what you think. So like, here's our parent function right there. The x minus 2 inside actually shifted it to the right. The x plus 3 inside actually shifted it to the left, okay? So it's going to be opposite of the sign if it's inside. If it's outside, it's going to move up or down exactly like you would think. If it's inside, it moves left or right, opposite of what you think. And one more thing here with the reflection. If there's a negative in the front, like outside the absolute value, outside the linear, whatever, that negative sign in the front reflects there's the parent function, it reflects it across the x-axis, it turns it upside down. Okay, so let's look at a couple examples here. The first one says that f of x equals 2x plus 1. Write a new function g, that's this function right here shifted 3 down. So I'm going to take this right here, that f of x, and write a g of x, because it says function g, and shift this 3 units down, or translate it 3 units down. Now, when you go up or down, remember you just add a number to the end. Because it's 3 units down, I'm just going to put a minus 3 at the end, add what I can. There's g of x. G of x is 2x minus 2. There's my new function. Okay, part B says, write a function h of x that's translated 2 units to the left. Okay, now when you go left or right, the number has to be inside with the x to go left or right. So because it says left 2, I'm actually going to put plus 2, because when you go left or right, remember it's opposite of what you think. And don't forget the plus 1 we had out here. So we'll do all the work that you can. Distribute the 2. Let's add the 4 plus 1 there. So my final h of x function, 2x plus 5. So again, if you're going to shift a graph up or down, you add the number at the end, and that's exactly what you think. If you're going to shift it left or right, you add the number inside, opposite of what you think. Okay, now we're going to talk about reflections real quick. We talked about this a second ago. If there's a negative in the front, like that one right there, see where the negative sign is? It's in the front of the f of x, in front of the function. It actually reflects your graph across the x-axis. It flips it upside down. If the negative is inside the function, like inside the absolute value, inside the linear, it reflects across the y-axis. So one more time, a negative in the front reflects it across the x, or upside down. The negative in front of the inside reflects it across the y, which is sideways. And I'm going to show you an example here on the next slide. Okay. Same kind of example we looked at a second ago, except this is going to be reflection. There's our function, x plus 3 plus 1, absolute value. Write a function g whose graph is a reflection of the x-axis. Now, if it's the x-axis, remember, the negative goes in the front. So I'm going to put the negative there in the front of the absolute value, and that's it. That's all you got to worry about for reflect across the x. The y is a little bit different. I should have put g right there. I said function g. That's my fault. The part B says write a function h, where's a reflection in the y-axis. Now, if it's a reflection in the y-axis, the negative goes inside. Now, when you put the negative inside, you gotta remember it goes for everything inside. So I'm gonna put this x plus 3 in little parentheses because that negative sign goes for everything in there. So if I distribute that negative in here, I'm gonna get negative x minus 3 plus 1. Now, that's a good enough answer right there. However, think about what absolute value means. Absolute value of a negative, which is what this is the exact opposite. Like the absolute value of negative 7 is positive 7. The absolute value of negative 5 is positive 5. So the absolute value of negative x minus 3 is the opposite of that, which is x plus 3 plus 1. Okay, so the weird thing is this is pretty much the same function we started with, because think about it. If you graph absolute value, it's a v. What happens if you reflect the v sideways? Like you just flip it over. If you flip it over, it looks exactly the same. So absolute value is one of those weird ones where if you reflect it across the y, it looks the same as it did before you reflected it across the y. I hope that makes some sense. We'll work on these tomorrow and get really good at it. So I'll see you then.